So on this problem, we need to verify that Rolle's theorem applies. So if we're looking at the graph of sine of 5x, it needs to be continuous and differentiable. And it is. So Rolle's theorem specifically is also when f of 2 pi over 5 minus f of pi over 5 divided by 2 pi over 5 minus pi over 5 equals 0. And in this case, it turns out that way. If I graph the function, right, sine of x would look like this. Of course, it would keep going. It would have a period of 2 pi, so 0 to 2 pi. Now the 5 here in the problem tells me I am going to change the period. Instead of going from 0 to 2 pi, it goes from 0 to 2 pi over 5, right? So this is my new period, so this is going to end up being sine of 5x. Right? So originally, in the graph of sine, this would have been pi, but now it's going to be pi over 5. Right? So this point here is going to be my first endpoint. And then it turns out we go from pi over 5 to 2 pi over 5. This is my second point here. The function is continuous and differentiable, and you can kind of expect to see where the derivative equals the slope between those 2 points, right? So we're expecting it to happen one time. Sometimes it's nice to kind of graph the function and get an idea of how many times it could possibly happen within that interval. If the interval was 0 to 2 pi over 5, we would have actually had 2 solutions where the slope could be 0 at. But now we're only expecting to have one solution, and one solution is going to be in between pi over 5 and 2 pi over 5. So looking at the calculus here, we says when does f of x equal 0? Because that's the slope of the secant line. So differentiating this function is going to be 5 cosine of 5x. When does that equal 0? Well, that equals 0 when cosine of 5x equals 0. And if you recall from trig, cosine equals 0 at pi over 2 and 3 pi over 2, but that's just cosine, and we have cosine of 5x here. So we're really looking, when does 5x equal pi over 2, 5x equal 3 pi over 2. This is when x is pi over 10 or x is 3 pi over 10. Pi over 10 is not in our interval. It actually is right here. So that's not going to work in this solution, and it turns out our answer is 3 pi over 10, which is halfway between pi over 5 and 2 pi over 5. So some of the problems that come up in this section might use quite a bit of trig, but keep in mind you can use the online graphing calculator to kind of get an idea what's going on. You can use kind of some other resources to kind of see the function and how that's going on. You could have also graphed the derivative. So cosine of the function 0 to 2 pi, of course everything's divided by 5. So this here would have been the point where it's 0, which would be pi over 10. I have to keep in mind, see, of my original interval, right? 2 pi over 5 in my original interval. My interval goes from pi over 5 to 2 pi over 5. Oh, sorry. I'm looking for where this is cosine of 5x, where it equals 0, not where the slope's 0. Sorry about that. So this point here would be pi over 10. And then this point here would be 3 pi over 10. And that is actually the solution in this interval. So hopefully this helped. If you have any other questions, please let me know.